Welcome to this comprehensive tutorial where we'll dive deep into implementing secure backup and restore procedures within our Java applications. Today, we'll cover essential concepts, design patterns, and specific Java libraries that will help us achieve secure data management. Before we jump into the code, let's first clarify what we mean by secure backup and restore. A secure backup is a copy of data that is protected against unauthorized access and corruption. The restore process refers to the retrieval of that data when it is needed, ensuring integrity and confidentiality. We'll outline three key areas we need to focus on: encryption, data integrity, and secure storage. Let's go through each of these concepts, starting with encryption. In Java, we typically use the Java Cryptography Architecture, JCA, for encryption. Let's create a utility class responsible for basic encryption and decryption of files. We will be using AES, Advanced Encryption Standard, for this purpose. In this class, we define methods to generate a secret key, encrypt data, and decrypt data using AES. We will be using this class for backup data. Next, let's implement methods to handle the backup functionality. Our backup process will simply read data from a source file, encrypt it, and write it to a backup file. Here, we created a backup handler class, which includes a method to back up data. The data from source file path is read, encrypted, and saved to backup file path. Now, let's implement the restore functionality that reads the encrypted backup, decrypts it, and writes it back to the original file path. This ensures we can recover our data securely. With this restore method, we can retrieve our data securely. Let's ensure that our backup and restore operations handle errors gracefully. We'll use exceptions to catch any issues during these processes. Now that our basic backup and restore functionality is in place, let's move on to data integrity. It's critical that our backups are not only secure but also reliable. To ensure data integrity, we can use checksums. A checksum will allow us to confirm that our data has not been altered or corrupted. Let's implement this using the MD5 algorithm from the Java Security Package. In this checksum util class, we generate an MD5 checksum for a given byte array, which will help us verify the integrity of our backup files. Let's integrate the checksum generation in our backup process right after encryption. We will save both the backup file and its checksum in separate files. With this adjustment, we save a checksum file next to our encrypted backup, enhancing our data integrity checks. Now, let's add the verification step during the restore process, where we will read the checksum file and validate it against the decrypted data. By implementing this verification step, we confirm that the data we are restoring has not been tampered with or corrupted, ensuring its reliability. Now, let's discuss secure storage. It's vital to store our backup files in a place that protects them from unauthorized access. Common strategies include using cloud storage solutions with encryption capabilities or local storage with strict access control. If you're working with cloud services like AWS or Azure, they usually provide built-in mechanisms that you can leverage to secure your data. For local storage, make sure to set your file permissions correctly. Let's summarize the complete process we have created for secure backup and restore in Java. We built classes for encryption and checksum generation. We incorporated the actual backup and restore processes while ensuring both are secure, checking for data integrity. We also discussed the importance of secure storage practices, whether using local systems or cloud-based solutions. Before we conclude, it's important to note that security is an ongoing process. You should regularly review and update your security practices and keep up with the latest developments in cryptography and data security. Now let's put everything together in a small main application. This application will allow us to create a backup and restore it, giving us hands-on experience with what we've built. This main application interacts with users, allowing them to perform backup and restoration processes while handling exceptions. To wrap up, we covered a lot in this tutorial, from setting up encryption and ensuring data integrity to securing our backup storage. I hope you feel confident in implementing your backup and restore system now. If you found this tutorial helpful, please give it a thumbs up, subscribe for more Java tutorials, and don't hesitate to leave your questions or suggestions in the comments. Thank you for watching.